This is basically how to use a drop counter, and that's to automate the process and make titrations a lot faster. And so the only thing you need to do initially is a calibration, which is what we're doing here. And so the light gate, that little white thing at the bottom, that will count the drops as they go through. And so I just attach, so first I'm just going to calibrate it. So I'm just going to put some liquid in there that I'm going to use. So that's going to be the equivalent of the burette. Now there's the stopcock. There's two of them. So the first one you just fully open the bottom one. So that's like the on-off switch, and then the top one you can actually set the drops so that you can always know the controlled drops. So that's a little bit of an advantage over burette. So you can have the drops go like 2 a second or 1 a second, and then you use the bottom stopcock as an on-off button so that you always know what the rate of drops are going to be to get a nice even curve or whatever. Okay, and so I'm just setting the number of drops there. So now I'm just going to put a measuring cylinder underneath, and then that's going to tell me how many mils, the volume, and the light gate will take care of taking how many drops there are. And so you go over to the volume on the computer, press calibrate, click on fluid volume, and then you just let a few drops go through. Once you're happy enough drops have gone through, you can just stop the drops. Just take a reading on the measuring cylinder then and type in the volume you see on the measuring cylinder. Press set calibration. It's counted the number of drops all along, and then press OK and you're done. So now I'm just taking an aliquot of the unknown solution. For this one, it's sodium hydrogen carbonate. And then I just release that into the beaker and put it on the stirrer. Now when I put the pH meter on there, I'm just going to give it a rinse so there's no contaminating buffer on there. And I put the stirrer on the end of the pH meter, and I turn on the stirrer just to make sure it works. Now there's not enough liquid to cover it, so I just top up the beaker with a little bit more water so the stirrer can mix all the chemicals around. So almost good to go. I press start on the computer. Just see that it's the pH is stabilized, and now I can let the drops out. And so you can see the computer is taking a record of how many drops there are, therefore it knows the volume, and at the same time the pH meter is taking a record of the pH. Now when the pH drops suddenly, then you know that the solution has been neutralized and the reactions is finished. And so you can remove that one and just repeat the whole process so you can get a second trial. And again, once the pH has had a sudden drop, you know it's been neutralized. Now, just to process the data, it's easy just to put all the runs up at once. And then you grab the gradient button and you draw the gradient on and trying to find out where the steepest point is, the halfway in between, and that's where it's neutralized. And once you do that, you can see how many seconds into it that each one has taken. So then you can go to the second graph and go to the same number of seconds for both pH changes. And so you go to the bottom one and you go to the same number of seconds for both the blue and the pink one. And that'll tell you exactly how many mils had gone through at that number of seconds. So going off those readings, would be nice to do it a little bit better, maybe do a third trial. It is within 0.1, which is not brilliant. It would be better to be 0.05, but we'll just run with this. The whole thing took about 20 minutes, including the setup, calibration, and the 2 trials. So it is a lot faster than a normal titration. And once you've done it once, it's a matter of a couple of minutes to do each one. Because all you're doing is putting a new aliquot in there and just pressing play, basically. And so doing the stoichiometry calculations, so labeled formula, substitute units. So there's about that many moles of HCl. That was the given value on the bottle. That's the ratio, so it's 1:1. So we neutralized about this many moles of sodium hydrogen carbonate. And so the concentration, because we used 10 ml aliquots in that beaker, was 0.154 moles per litre. Okay, so have a look at the other titration videos if you want how to do the uncertainties for that. And hopefully that will speed you up with your titrations.